Good morning guys, welcome back in the next video of stability series. So in this video today we are going to start our chapter 8, that is center of buoyancy. Basically it's numericals we are going to do. But before starting this video, I want to share something with you. I hope you have watched my both of the videos in which I have did the sign on and I have taken the sign off from the first ship. So my first ship was an oil tanker and the experience was very excellent. My captain, chief officer, second officer, third officer, everyone was very amazing and very good. So engineers also good, ratings, deck ratings, engine ratings, everyone is very good. Means all the crew including the master is very good. So my first ship was an oil tanker. She was an 1,12,700 metric tons crude oil carrier. So I have started my journey from Singapore to Russia and then Russia to Singapore. So this is all about my first ship journey. I will elaborate in next video, so be prepared for that and be ready for that. So without wasting time, let's start this video. So center of buoyancy. So first start with the basic intros. So the center of buoyancy, B or COB, which we used to refer the center of buoyancy point of a ship, is that point through which the force of buoyancy may be considered to act vertically upwards with a force equal to the weight of the water displaced by the ship. It is the geometric center of the water displaced, that is the geometric center of the underwater volume of the ship. So you can see in the diagram and you can refer to the definition. Okay. The position of the COB of a ship is indicated by the height above the keel. This distance is called KB. K means keel, B means buoyancy. So KB. The distance from the AP means after perpendicular of the ship. You can see this is the after perpendicular and this is the point of buoyancy. So buoyancy B and after perpendicular A, that is called, this distance is called AB. Some shipyards use a midship H for reference instead of the after perpendicular A. So in this case, the COB is then referred to as HB. It must be stated whether the COB is forward or above the midship in each case. If the vessel is upright and on an even keel, the KB of a box-shaped vessel would be exactly half the draft and KB of a triangular shaped vessel would be 2/3 of its draft. So KB will be draft by 2 if your ship hull is if your underwater volume of the ship is a box-shaped vessel, and KB will be 2/3 into its draft if the hull is of triangular shape. Now it's time to do some numericals. So first numerical says that a box-shaped vessel of a displacement 1,640 tons is 50 meter long, 10 meter wide and 8 meter high. Find her KB in salt water if she is on an even keel, if she is on an even keel and upright. Okay, there is some typo error. So first of all guys, write the given data in every question. So displacement is 1,640 tons. Volume of vessel will be length into breadth into height, which is 50, 10, 8, which equals to the 4,000 meter cube. Now relative density is 1.025 because the salt water is given. Displacement we will find and we will put the data into this format, that is displacement is equals to underwater volume into density of water displaced. So 1640 is equals to length, breadth, depth multiplied by 1.025. Now if we will solve for the draft will be 3.2 meters and the KB will be draft by 2, that is 1.6 meters. Now question 2 says that a box shaped vessel 60 meter into 10 meter into 10 meter floats in a dock water of RD 1.020 at an even keel draft of 6 meters. Find her KB in dock water of RD 1.004. So guys, there is a one ship which is floating in two kinds of water. Okay, first is the relative density of first one is 1.020 and second one is 1.004. So we have to find her KB in the second waters. So volume will be 6,000 meter cube, either in 1.020, either in 1.004. The volume will be same. Okay. Relative density will be 1.020, draft 6 meters. This is the given data. So we will use the displacement formula and displacement in first case will be 3,672 tons. Okay, calculating the draft at RD 1.004 will be 3672 60 into 10 into D multiplied by 1004. Okay, once the draft will change, the volume will change. So draft will be this much, 3672 divided by 60 10 1.004, which is equals to 6.095 meters. Now kb will be draft by 2, so it will be 3.048 meters. Question 3 says that a triangular shaped vessel of a displacement 650 tons floats in dock water of relative density 1.015. Her water plane is a rectangle 30 meter into 8 meter. Find her kb. Okay. So guys, displacement will be 650 ton, it is given. Relative density is given. Water plane area will be 30 into 8, which is equals to 240 meter square. This is area, that is why it is square. If it is volume, it will be in the cube. So formula for volume of triangle will be half into L into B into H. Everyone knows. Displacement formula again we will use. So displacement will be 650 is equals to 1 by 2. Length into breadth into depth into density. So we know the length and breadth. Our water plane is 30 into 8. This is its length and breadth. So we have all the data, but just we have to solve for the D, that is draft. So 650 will be 1 by 2, 30 into 8 into D into 1.015. So once you solve for the draft will be 5.336. Now the vessel is in triangular shape. So we will change the formula here. For triangular, kb will be 2 by 3 into its draft. So 2 by 3 multiplied by 5.336 will be equals to the 3.558 meters will be the kb of this triangular shaped vessel. Okay. Next question says that a triangular shaped vessel floats in salt water. Her water plane is a rectangle 40 meter into 12 meter. If her kb is 3.6 meter, find her displacement. Okay. So guys, in this case, we have to find the displacement. But what the things we have? We have the length, that is 40. We have the breadth, that is 12, because her water plane is a rectangle. So 40 into 12 will be the area. kb is given. So we will use the formula to find the draft. So once we will have the draft, we will have the length, we will have the breadth, we will find the volume. And this is floating in the salt water. So once we will multiply the salt water density with the given volume, it will give the displacement. Okay. See, water plane area is 480 meters square. Initial kb is 3.6. So we know that for the triangle, kb will be 2 by 3 into its draft. So 3.6 is the kb, 2 by 3 into draft. So we will solve for the draft, which is equals to the 5.4 meters. Now we will use the formula to find the volume of triangular. So 1 by 2 into L into B into H. Okay. So displacement will be underwater volume multiplied by density. Now displacement 1 by 2 into length into breadth into draft. Density we know it is salt water. So 1.025. Now if we will solve for the displacement, 1328.4 ton will be our displacement. This is final answer. Question 5 says that a homogeneous log of wood 3 meter into 0.75 meters multiplied by 0.75 meters floats in salt water with one face horizontal. If the RD of the log is 0.8 meters, calculate the vertical distance between its COG and its COB. So guys, COG and COB are two different concepts. COB stands for center of buoyancy, which remains in the underwater of the ship. COG stands for the center of gravity, which remains out of the water on the body of a ship. Okay. So volume of log of wood will be 1.688 meter cube. Relative density we know 1.025 and relative density of log will be 0.8 meters. So we have to find the mass of log. So volume will be volume multiplied by density is equals to the 1.688 multiplied by 0.8, which is equals to the 1.35 tons. So 1.35 tons will be the mass of basically the displacement of that homogeneous log of wood. Okay. Now we will use the formula, that is displacement volume multiplied by density, to find the draft, and draft will be 0.585. Now COB will be 1 by 2 into draft. COB, KB and COB means we have to find the point of buoyancy. So the draft will be 0.585. COB which is equals to the KB which is equals to the 1 by 2 into draft which is equals to the 0.293. Now if you have to find the buoyancy, for a box shaped vessel, what you have to do, you have to multiply the draft by 2. But when you have to find the COG, we have to divide the height by 2. So its total height will be 0.75 already given in the question. So 0.75 divided by 2 which is equals to the 0.375 meters. Now if we will subtract the COB from the COG, the distance will be 0.082 meters. Okay guys, so this is our fifth question has been completed. Let's move for the sixth. Question 6 says that a homogeneous log of wood 0.5 meter square section floats in a water of RD 1.005 at a draft of 0.4 meters. With one of its faces horizontal, find the vertical distance between its COG and its COB in water of RD 1.020. Okay guys, so again in this video we have to find the distance between the COG and its COB. So once that log of wood will be in the 1.020 density of waters, so what will be its COB and its COG? COG will remain same because COG will be the height by 2, height will remain same, but the COB will change according to the draft because the volume will slightly change. So let's start with the given data. So RD is 1.005 and draft will be 0.4 meters. So mass will be volume multiplied by density which is equals to 0.1005 tons. Displacement will be area into draft. Area into draft will be volume multiplied by density. So we have the displacement as follows: 0.1005. Area we know 0.5, 0.5 because it is a square section and homogeneous. So 0.5 will remain same for all the sides. So draft we have to find, density we know. Draft will be 0.394. COB will be draft by 2, that is 0.197 meters. Now COB will be 0.5 divided by 2, basically that is the height divided by 2, which equals to the 0.25 meters. Once we will minus COG minus COB, the answer will be 0.053 meters. Question 7 says that a cylindrical drum of 0.8 meter diameter and 1.5 meter height, weight 10 kg, 490 kg of steel is put in it such that it floats with its axis vertical in fresh water. Find its KB. Assume pi to be 22 by 7. Okay. So diameter is 0.8 meters, which means radius will be 0.4. Height 1.5. Now guys, in stability, always we talk about the displacement in terms of tons. But in this question, the unit of the weight is given in kilograms. So we have to convert from kilograms to the tons. So weight will be 10 kilogram, which is equal to the 0.01 ton. And mass of steel will be 490 kg, which is equal to the 0.49 tons. Total will be the 0.50 tons. So 0.50 tons will be our final displacement. We will take this number for the whole calculation. Now displacement will be underwater volume multiplied by density. As it is a cylindrical drum, so volume formula will be pi r square h. So 0.5 will be pi r square h into density. So we have the density for the fresh water, which is 1. We have to find the draft. Displacement we already find. Pi r square h means value of the pi will be 22 by 7, which is equal to the 3.1416 multiplied by 0.4. Basically it's the radius. So D will be, the draft will be 0.995. Again KB will be calculated as draft by 2, which is equals to the 0.497 meters. Now question 8, question 9 and question 10. There will be a diagram given in the description box. There will be a link for the diagram for these 3 questions. So you have to draw the diagram. I don't have space here, so I can't show the diagrams, but you have to use the diagram to connect the question with the diagram. So question 8 says that a barge prism shaped such that its deck and keel are identical and parallel. Its side vertical, its deck consists of three shapes: triangular bow of 12 meter each side, rectangular mid part 80 meter long and 12 meter wide, semicircular stern of radius 6 meter. If the light displacement of the barge is 500 ton and it has 5000 ton of cargo in it, find its kb when floating on an even keel in salt water, and assume pi to be 3.142. Pi is given because of the semicircular stern of radius 6 meters. So guys, again I am telling you, check the description for the three diagrams of the question 8, question 9 and question 10. Okay, so total displacement will be 5500 tons. Now, area of semicircle AFT, which is equals to the pi r square divided by 2, which is equals to the 56.556 meter square. Area of rectangle will be 80 into 12, which equals to the 960 meter square. Area of triangle BEC will be half into B into H, which is equals to the 62.34 meter square. So total area will be 1078.89 meter square. Now in triangle BC we will use the Pythagorean theorem. So EG square will be BE square minus BG square, which equals to the 108 if you solve completely. So EG will be 10.9 meters, that is will be the height of the triangle. So displacement formula we will use again. So 5500 will be equals to the area multiplied by depth multiplied by density. Again we have to find the draft. So draft will be 5500 divided by 1078.89 multiplied by density of the salt water, which equals to the 4.97 meters. Now kb will be draft by 2, which equals to the 2.485 meters. Okay. Question 9 says that the deck and keel of a flat bottom barge are identical. Its sides are vertical. The deck consists of two sections. The bow is a triangle 12 meter broad and measures 12 meter in the fore and aft direction. The mid body is a rectangle 50 meter long and 12 meter broad. If it is floating on an even keel in salt water with a displacement of 3444 ton, find the position of its COB with reference to its after end. Okay. So again you have to use the diagram given in the description. So total displacement will be 3444 tons. So displacement formula we will use volume into density. Now 344 will be equals to the volume of triangle plus volume of rectangle multiplied by salt water density. Now from the question we will put the data into the formula, and final the draft will be 344 divided by 688.8, which equals to the 5 meters, which means the COB will be 2.5 meters because 5 divided by 2 is 2.5 meters. Now COB with reference to after end will be total moment of barge multiplied by the moment of triangle plus moment of rectangle. So total moment of barge will be displacement multiplied by LCP of barge, which equals to the underwater volume multiplied by density into the LCP. Guys, you have to use this formula, underwater volume multiplied by density multiplied by LCP 2 times. One for the data given for the triangle, another time for the data given for the rectangle. So I will use this LCB of barge here, 344 multiplied by LCB. This is the data given for the triangle. Now I have kept plus here and we will put the rectangle data also here. So total if you solve, it will be LCB is equals to 96801 divided by 3444. So LCB will be 28.10 meters. Question 10 says that a barge of 45 meter long has a uniform transverse cross section throughout, which consists of a rectangle above a triangle. The rectangle is 8 meter broad, 4 meter high. The triangle is apex downwards, 8 meter broad and 3 meters deep. Okay. If displacement of the barge is 1620 tons, find the position of its COB with reference to the keel and also with the reference to the after end, if it is upright and on an even keel in fresh water. Guys, again you have to use the diagram which is I have already given. The link via the link in the description box. So total displacement will be 1620 tons. Let x ton of weight which is not displaced by triangle. So weight displaced is 1620 minus x tons. Volume of triangle will be 540 meter cube. Displacement will be the 540 multiplied by 1, which is equals to the 540 tons, which is equals to the x. So displacement of rectangle, 540 ton is a displacement of that triangle, and displacement of rectangle will be 1620 minus x. So final displacement will be the 1080 tons. Displacement for rectangle will be equals to the underwater volume multiplied by density. 1080 is equals to the 45 meter multiplied by 8 meter into the draft into 1. So we have to find the draft of the rectangle because the triangle is the vertically upright. Okay, so draft will be 3 meters and COB will be 1.5 meters. Now guys, we have to find its. So COB with respect to keel is equals to 4.5 meters. Now guys, we have vertical movement of triangle which is equals to the displacement multiplied by draft, which equals to the 540 into 2, which is equals to the 1080. Now vertical movement of triangle will be 4860. So final vertical movement will be triangle plus rectangle, which is equals to the 5940. Okay, final weight will be 1620 tons. Final kb will be final vertical movement divided by final weight. So guys, keep this formula in your hand or in your mind. So final kb will be final vertical movement divided by final weight, basically displacement. So which is equal to the 3.66 meters. So total moment of barge will be moment of triangle plus rectangle. 1620 into LCB of barge, underwater volume multiplied by density into the LCB. So this is the standard, basically the total volume or the total data. But for movement of triangle and movement of rectangle, we have to use this single formula 2 times. So underwater volume of the triangle will be as follows: 540 into 1 into 22.5 plus 1080 multiplied by 1 into 22.5. So finally, the LCB will be 36450 divided by 1620. So LCB, which is equals to the AB, so it is equal to the 22.5 meters. Basically, our question 10 has completed. So this is all for today guys. Thank you very much. I hope you like the video, you like the new theme to do the things. So we will meet in the next video of chapter 9, that is the writing lever. So without wasting time, let's end the video and we'll move to the next video. Till then, Jai Hind, Jai Bharat, Vande Mataram.